In this video, I am going to explain you the division instruction and how it will be executed in our 8086 assembly language programming. So the syntax for writing our division instruction is DIV and our source register. So our source may be 8-bit, that is byte, or it may be 16-bit, that is word. So depending on the source register, the operation will be performed and our value of quotient and remainder will be stored in our respective register. So first of all, we will check how the instruction will be executed if the source is 8-bit. So if the source is 8-bit, that is byte, that time we are storing our quotient into our AL register. And if the source is byte, then we are storing our remainder into our AH register. In case of word operation, if the source is word, that is 16-bit, that time we are storing our quotient into our AX register and our remainder will be stored into our DX register. So here in the example, what is given? Move AL, 62H. So whenever we are performing this move instruction, that time we are copying the contents of source into our destination register. And our destination register is AL register. It is also 8-bit register. So I am writing here AL is equal to 62H. That is our hexadecimal value. Then we are writing here move BL, 11H. So here I am writing BL is equal to 11H. So now both the register is having the contents, that is AL and BL is equal to 62 and 11H respectively. Now we have to perform the division instruction. So here division BL is written. So our BL is 8-bit register, that is called as a 8-bit unsigned source register. So whenever we have to perform this division instruction, that time we are checking if the source is 8-bit or 16-bit. So whenever it is 8-bit, then our quotient will be stored in our AL register. So I am writing here AL divided by our unsigned 8-bit source, that is our BL register. And our remainder will be stored it into AH is equal to AL mod of BL. So whenever we are putting the value, that time we got our result. So I'm writing here 62 divided by 11 and here 62 mod of 11. So 62 divided by 11, we got the number that is 05. After performing the division, we got 5 as a quotient, because whenever we are dividing the 62 divided by 11, then 11 5s are 55 and our remainder will be 7. So 05 is our quotient and 07 is our remainder. So I'm writing here the quotient value that will be stored into our AL register, that is 05H, and the contents of our remainder will be stored it into the AH register, that is called as a 07H. Now this will be completed with our 8-bit register. Now the second example is move AX, 1234H. So our AX register become 1234H. That is our hexadecimal value. And our BX is equal to 12H. So I am writing here 0012H. So these are the contents after performing this move AX, 1234H and move BX, 12H. So we have copied the contents of 1234 into our AX register and 12H into our BX register. Now we have to perform the division instruction. So in case of division instruction, our source is 16-bit. So our BX register is 16-bit. So our source is 16-bit. That is the word operation will be carried out. So whenever our source is word, that time we are storing the quotient into AX register and we are storing the remainder into DX register. So I'm writing here AX is equal to, how the operation will be performed? We are taking here dx colon ax. If the source is, if the destination is our byte, that time we are taking their dx colon ax. So it will become a 32 bit of our data. But here there is not requirement of our 32 bit of data. So I'm directly taking here AX divided by our BX register, that is our unsigned 16 bit source. So why it is called as unsigned? Because this is our positive number, not a negative number. So that here written unsigned 16 bit source. Now in case of DX register, it will store the remainder of our AX mod of BX. So whenever you are putting this value, that is 1234H divided by 0012H, that time we got the number 102H in our AX register. So I'm writing here 0102H, and that data will be stored it into the AX register. So our quotient will be AX register and our remainder will be stored in our DX register. So I'm writing here DX is equal to AX mod of BX. So that is 1234 mod of 0012. So after performing the operation, we will get a remainder as 10H. So 1234 divided by 12, you got the number, that is 12 here, that is 00, then here it is 3, then it is 0, here I am writing 3, and this is the 4. So here you are writing here 24, and you got the result 10. So you got this number as a 102 as a quotient and 10 as a remainder. So we have written this quotient AX is equal to 0102H, and our remainder is equal to, that is DX register is equal to 0010H. So you have to remember that whenever you are performing the division instruction, we have to check our source is 8-bit or 16-bit. If it is a 8-bit, then our quotient will be stored in our AX register and our remainder will be stored in our AH register. If it is a 16-bit, then our quotient will be stored it into the AX register and our remainder will be stored in our DX register. So in this way, our division instruction will be executed in our 8086 microprocessor programming.